Welcome back, students. This is Himisha Bajaj and we are going to start with the next chapter, Computer Memory. The topics covered in this chapter are: what is computer memory, which are the different memory units, the types of computer memory, what is primary memory, types of RAM and ROM, cache memory, what do you understand by secondary memory and what is its significance, hard disk and its characteristics, and the different types of hard disk. So let us understand what is computer memory. It is the basic unit where data and instructions are stored temporarily. Memory consists of one or more chips on the motherboard, as you can see in the picture. It stores the unprocessed as well as processed instructions. There are additional memory devices which store the data and instructions permanently. So to summarize, computer memory is the basic storage area or unit of the computer system. Now we are going to see the memory units of the computer memory. Computer memory can be measured in bits or bytes. A computer processes and stores data and instructions in the form of two digits 0 and 1. These digits are called binary digits or bits. A bit is the smallest unit of information that a computer can process and store. You must remember this, that a group of 4 bits is known as a nibble. A group of 8 bits is called a byte. A byte is the minimum space required to store a character. Now let us understand the units of measurement. 1 byte is equal to 1 character, which means any character that you type through the keyboard occupies 1 byte of memory space. 1 kilobyte or KB is equal to 1024 bytes, about 1000 characters approximately. 1 megabyte or MB is equal to 1024 KB, that is about 1 million characters. 1 GB or gigabyte is equal to 1024 MB, that is about 1 billion characters, and so on. So from this slide you can make out the different units of measurement for the computer memory. So if you say that my pen drive has got 1 TB capacity, that means it is capable of storing 1 trillion characters in the memory. Now let us understand different units of memory in a different way. We try to compare the units of memory with different components of library. Here you can see that byte is highlighted with a letter L. 1 byte is equivalent to 1 character. A character can be a number, letter, or symbol. 1 byte consists of 8 bits. A bit is the smallest unit of information a computer can process. So we can say that every character that you type through the keyboard occupies 1 byte of computer memory. We go to the next memory unit, that is kilobyte. 1 kilobyte is equivalent to 1024 bytes. This is approximately equal to 1 page of text of a book. So we are trying to compare KB with a page of a book. Next unit is megabyte or MB. 1 equivalent to 1024 KB. This is approximately equal to 1 book. So we are trying to compare MB with a book. Next unit is gigabyte or GB. 1 GB is equivalent to 1024 megabytes. This is approximately equal to bunch of books. Next unit is terabyte, which is TB. 1 terabyte is 1024 GBs. This is approximately equivalent to entire book stand. And the next unit is petabyte, PB. 1 petabyte is equivalent to 1024 terabytes or TB. This is approximately equal to a room full of books. By creating this simile, maybe you are able to understand the different units of memory in a better way. Now we come to the next topic, types of computer memory. Computer memory is divided into two types, primary and secondary. You can see in this picture, RAM is an example of primary memory and floppy disk, hard disk, CD and pen drive. These are the examples of secondary memory. Now let us understand what is primary memory. It is also known as the working memory or the main memory of the computer system. Primary memory is of two types, volatile and non-volatile. Volatile means the contents get erased when the power is switched off. Non-volatile means the contents do not get erased when the power is switched off. RAM and ROM are two examples of primary memory. A computer cannot run without primary memory. RAM is an example of primary memory. The full form of RAM is random access memory. It consists of memory chips that can be read from and written to by the processor and other devices. When you turn on the computer, some operating system files are loaded into RAM from a storage device like hard disk. These files remain in RAM as long as the computer is on. Additional applications and data are also loaded into RAM from storage device. Hence, we can say that RAM is the working memory of the computer system. It is also called the main memory of the computer system. Since RAM is the working memory of the computer system, CPU interprets and executes a program or application while it is there in RAM. RAM can accommodate multiple programs and applications simultaneously. RAM is a volatile memory. It loses its contents when the computer is switched off. Saving is the process of copying items from RAM to the hard disk. Now let us see the different types of RAM. There are three common types of RAM chips: dynamic, static, and magnetoresistive. Now let us understand the first type of RAM, DRAM or dynamic RAM. It is inexpensive and the most popular type of main memory used in computers. There are many variants of DRAM that are faster than basic DRAM. The first variant is SDRAM or synchronous DRAM. It is faster and more reliable than DRAM. Another variant is DDR SDRAM, which is double data rate SDRAM. It is faster than SDRAM and transfers data twice instead of once for each clock cycle of CPU. The third variant of DRAM is DDR2. It is the second generation of DDR with faster speed. The fourth variant is DDR3. It is the third generation of DDR which is designed for computers with multi-core processors. It is faster than DDR2. The fifth variant is DDR4. It is the fourth generation of DDR which is faster than DDR3. And the last variant is RDRAM, which is Rambus DRAM. It is faster than SDRAM. You can see here on the slide the picture of RDRAM. The next type of RAM is static RAM or SRAM. It is efficient and fast but is very expensive. It is used in small amounts as cache memory in a computer. Cache memory improves the performance of a computer by storing the data which the computer frequently uses. The third type of RAM is magnetoresistive RAM or MRAM. It is a newer type of RAM which stores data using magnetic charges instead of electrical charges. MRAM has great storage capacity, consumes less power, and has faster access time than other RAMs. MRAM retains its contents after the computer is switched off, which could prevent loss of data for users. It has a high speed of static RAM and high density of DRAM, enabling it to be accessed faster, consuming less battery power. So we have seen three different types of RAM: DRAM, SRAM, and MRAM. This is a picture of a memory module. You can see here that several memory chips are mounted on the memory module. Let us understand on the next slide what is memory module. A memory module is a circuit board that holds memory chips. RAM is a type of memory chip that makes up the main memory in the computer system. There are two types of memory modules, SIMs and DIMMs. The full form of SIM is Single Inline Memory Module. A single inline memory module has pins on opposite sides of the circuit board that connect to form a single set of contacts. Let us see the picture of a SIM on the next slide. The picture that you see here is a SIM, and all the memory chips have pins on the opposite sides that form single set of contacts. The second type of memory module is a DIMM. The full form of DIMM is Dual Inline Memory Module. With DIMM, by contrast, the pins that are on the opposite sides of circuit board do not connect and thus form two sets of contacts. In the picture here, you can clearly make out the difference between SIM and DIMM. Now we understand the significance or importance of RAM in a computer system. The amount of RAM determines the amount of programs and data a computer can handle at one time, which affects the overall performance of a computer system. The computer can only manipulate data that is in its main memory or RAM. More the RAM, faster the computer will respond. The second example of primary memory is ROM. The full form is read-only memory. It refers to the memory chips used for storing data that can be read only. The data on ROM cannot be modified, hence the name read-only memory. ROM is non-volatile. Its contents are not lost when the computer is switched off. ROM contains the basic input-output system, that is BIOS, which is a sequence of instructions that the computer executes to load operating system and other files when you turn on the computer. Now let us see the different types of ROM. The first type is PROM. The full form is Programmable Read-Only Memory. It is a blank ROM chip on which instructions can be stored permanently. The next type is EEPROM, which is Erasable Programmable Read-Only Memory. It is a type of ROM, the contents of which are erased by ultraviolet light and then can be reprogrammed. The third type is EEPROM, which is Electrically Erasable Programmable Read-Only Memory. It allows the programmer to erase the microcode with an electric signal. You can see all the three different types of ROM on the slide. The next type of memory is cache memory. It is a temporary storage area for instructions and data that enhances the CPU speed. The CPU can access the data that is stored in cache memory faster than the data that is stored in RAM. Cache improves the processing speed of the computer because it stores frequently used instructions and data. There are three layers or types of cache memory: L1 cache, L2 cache, and L3 cache. Here on the slide you can see the picture of cache memory. Now let us see the three types of cache memory. L1 cache is high-speed memory built directly on the processor chip. It usually has a very small capacity. L2 cache is slightly slower than L1 cache but has much larger capacity. L3 cache is a cache on the motherboard that is separate from the processor chip. So out of these three types of cache memory, L1 cache is the memory which is accessed at a very high speed by the CPU. Now let us learn what is secondary memory. We all know that primary memory has a limitation because it is a volatile memory, which means when the power is switched off, all the contents stored in the primary memory get erased. In order to save the data permanently, we go for secondary memory. Let us see the features of secondary memory. It is used to store data for a long time. It is slower than primary memory. It is a non-volatile memory, and the examples of secondary memory are hard disk, pen drive, CDs, DVDs, etc. This is a hard disk. A hard disk is also called hard disk drive or HDD. It is a storage device that contains multiple platters coated with magnetic particles to store data. It is enclosed in an airtight sealed case to protect it from damage. It is mounted inside the computer case and is called fixed disk because it is not portable. In the picture here, you can see multiple platters which are used to store data. Now let us see the characteristics of hard disk. It is a read-write storage media, which means you can read data from the hard disk and also you can write data onto the hard disk. Before any data can be read or written on a hard disk, the disk must be formatted. What is formatting? It is a process of dividing the disk into tracks and sectors for storing and locating data. A track is a narrow recording band that forms a full circle on the surface of the disk. These tracks are further divided into pie-shaped sections called sectors. This picture shows the process of formatting. As you all can see here, the formatting is a process of dividing the disk into several concentric circles called tracks. These tracks are further divided into pie-shaped sections called sectors. Now let us understand the process of hard disk partitioning. After formatting, the hard disk can be divided into separate areas called partitions. Each partition functions as if it were a separate hard disk drive. Partitioning is often done to install multiple OS on the same hard disk. The default name given to the partition is drive C. If there are two partitions, then drive C and drive D, and so on. You can see here in the picture how disk is divided into two partitions, drive C and drive D after formatting. Now let us understand the process of defragmentation of hard drive. The performance of the hard drive could be improved by defragmenting the drive. A fragmented hard drive divides the file into parts and stores it in many different locations. To retrieve a file, the computer must access many areas of the drive. This might take a longer time for the hard disk to retrieve a file. A defragmentation program, when executed, places all the parts of a file in one location. This reduces the hard drive time to locate the file. Auto defragmentation is a process performed by most of the operating systems. This slide shows you the picture of a fragmented disk and defragmented disk. As you can see here, in the fragmentation process, the file is divided into several parts and is placed at different locations on the disk. Whereas in case of defragmented disk, all these fragments are put together at one location so that the hard disk drive can retrieve it faster. Now let us understand what do you mean by hard disk interface. It is the connection between the hard disk and the computer. It is also called hard disk controller or HDC. The different types of hard disk interfaces are SATA. The full form is Serial Advanced Technology Attachment. It is a hard disk interface that uses parallel signals to transfer data, instructions, and information. The next type of interface is Small Computer System Interface or SCSI. It uses parallel signals and can support up to 8 to 15 peripheral devices. The third type of interface is EIDE. The full form is Enhanced Integrated Drive Electronics. It uses parallel signals to transfer data, instructions, and information. The fourth type of interface is SAS or Serial Attached SCSI. It is a newer type of SCSI that uses serial signals to transfer data and information. On this slide, you can see the pictures of different types of hard disk interfaces. You can see the first picture is of a SATA cable, the next picture is EIDE cable, the third is SCSI cable, and the fourth one is SAS cable. Apart from the fixed or internal hard disk, the other two types of hard disks are external hard drive and miniature hard drive. The external hard drive is a portable hard disk that connects to the USB port in the system. It is enclosed in an airtight sealed case. The next type is miniature hard drive or hard disk. These small hard disks are available in sizes about 1.8 inch, 1 inch and 0.85 inches respectively, almost like a size of a key. It is used mainly in portable media players, digital cameras and smartphones. This slide shows you the picture of an external hard disk and a miniature hard disk. Now let us understand the process of restoring the deleted files from the hard disk. Once the files are deleted from the hard disk, what is the method to retrieve or restore these deleted files back? There are several ways to recover deleted files, no matter they were deleted by moving to the recycle bin, emptying the recycle bin, or by pressing the Shift plus Delete command. You can either use Windows built-in tools or deleted data recovery applications to get back your data. Data recovery software is specialized for permanently deleted cases or losing data without backups. There are three proven methods to recover deleted files. First one, recover deleted files with deleted file recovery software. Second, recover deleted files from recycle bin. And the third method is to restore deleted files from the previous version. With this, we come to an end of the presentation. I hope you all enjoyed it. Thank you.